Good afternoon, everybody. Video notes 4, first unit, matter and measurement, elements versus compounds today. When we are done, you will be able to differentiate between elements and compounds as we write them in our chemical notation. How do we get our information across? Notation. Identify the different elements by type and number present using those subscripts. We've used those in the POGIL. Remember those little tiny 2s or 3s? Sub means below, so subscript is below, not up top with the squared. We'll also be able to write element symbols using some rules that we'll learn so we get elements and compounds right all the time. So basically what we need to do right now is let's learn how we do these symbols. All right, so starts right off with practice. Elements versus compounds. We're going to circle the elements and underline the compounds. So CO, carbon is an element, oxygen is an element, two elements make a compound, underline. Mg is magnesium, it's an element. Cobalt is an element. I'm just going to do these first three. We're going to do the rest of the notes. I'm going to have you come back through and do this. Once you've learned this, everything that we have to teach you in this particular video lesson, this is going to be easy peasy. So, carbon is one atom, oxygen is one atom, that's two atoms. Making that compound, magnesium's all by itself one, cobalt, all by itself one. That's how we're going to do these. I see some parentheses and some more subscripts, so we're going to do the notes first. I'm going to have you guys come back and finish these up, and we'll see you tomorrow in class how they worked. Does each compound have the same number of symbols? No. I had one with two symbols. I had one with one symbol. Two with one symbol. For each element above, how many total symbols were listed? Each element gets one symbol. What is the maximum number of symbols that must be present in a compound? Compound is two or more elements, right out of the POGIL, right? So an element, the formula contains only one symbol, be it a capital letter and a little letter, or just one single capital letter. A compound, though, has to have two different elements in it, so hence two different element symbols. Okay? So on to rules, with some examples, of course. Within a compound, you might see these little subscripts. That's going to tell me how many of each atom there is. So I don't see a subscript on the carbon, but I see the symbol for carbon. So there's got to be at least one, right? So I'm going to draw in here a little one. Oh, sorry, came out a little big. He's a little one subscript. We don't have to write that one subscript in chemistry, but just because the symbol's there, there's at least one, right? So I have one carbon, and then the subscript on oxygen is 2. All right, now parentheses. This is where we get into algebra. At least the rules are the same, right? So if I wrote for you guys 2 times x plus 6, I have a feeling that you guys all have an instinct to distribute that 2, right? It'd be 2x plus 12. And you guys can do that, and you guys can go backwards. You learned how to do this in math class. Well, here's an example for chemistry. Al is outside the parentheses. It's going to have its little subscript of 1. I have 1 Al. But I'm going to distribute the 3 much like I would in algebra. So that's going to give me 3 carbons and 3 nitrogens. Okay? There's one other case that we got to check out. What happens if there's a subscript inside the parentheses? Rules still apply. If I were to write for you 2 times 2x plus 7, you'd still distribute, right? But now it would be 4x plus 14, because it would be 2 times 2. So the same rules are going to apply here. Subscript iron sulfate is this beast. I see the subscript of 2 after the iron, so there's 2 irons outside the parentheses. Then I'm going to distribute the 3. So remember there was a little 1 here on the sulfur. 3 times 1 is 3. And then 3 times 4 oxygens. 3 times 4 is 12. All right, I'm going to show you one other way to conceptualize this other than the algebra method. If I have 3 SO4s, what that means is I have SO4, 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 right? It's really what it means. I have 3 of these packets of these SO4s. How many sulfurs? I see 1, 2, 3. There we go. I got 3. And then I have 4 oxygens plus 4 oxygens is 8, plus 4 more oxygens is 12, 12 total oxygens. So whichever way this works for you to rationalize it in your brain, distribute the 3 or 3 packets of, either way comes out to the same answer, and I can count out atoms correctly. So the rules for writing elements. Ready? This is going to be for the whole year, guys. The first letter is always capitalized. You look at the periodic table, every letter up there that starts a symbol is capitalized. If there is a second letter, it's got to be lowercase. This is how I get around this. C, capital O, versus C, little o. This capital O tells me it's a separate element because the first letter is always capitalized. So that gives me a carbon and an oxygen. But if the second letter is lowercase, this goes with that C, this little o, so it's cobalt. Okay, and that's a rule that it's gonna be going on all year long. Before too long, it's gonna be common knowledge. You're gonna look at me and say, Mr. Mokes, really? Like, I know this already. And I'm gonna be like, good, because you need to use it. Here's a list of a bunch of the common elements that we'll be using and their names. You're going to find that every one of them is in table S when we get our reference tables. So it's time to wrap it up. Now you are able to differentiate between the symbols of single elements and compounds. You know the basic rules and 2 guidelines for writing them and how to use the subscripts to count. Now I want you to go back. I want you to finish the rest of those example problems that were there, and we're done. Just over 7 minutes, guys. See you in class tomorrow.